We have seen that the Internet model is the current architecture used to solve the complex network interconnection problem. In this video, Daniel will introduce all 5 layers, starting from the bottom, or layer number 1, up to the top of the model. Thanks for following this networking basics course.
So let's talk about the 5 layers of the Internet model in detail. At the very bottom, we have the so-called physical layer. It is a physical layer because it deals with physics, with electronics, optical signals, radio waves, and any system that needs to make communications possible. The units of data on the physical layer are called bits or symbols. These are transported through a physical medium like fiber and copper cables, as well as radio waves, where light pulses or electrical signals are used for communication. An example of devices operating on the physical layer is an optical transceiver or an electrical Ethernet port. Just have a look at the back of your computer to see if there is a network cable connected as a physical interface that drives electrical communication. We can find the so-called link layer one layer up, on layer number 2. On this layer, we refer to frames as pieces of information to be sent. Frames are built by merging a set of bits or symbols from the lower physical layer. The purpose of the link layer is to provide node-to-node data transfer, that is, from one computer to the next directly connected computer. Here, the idea of a network does not yet apply. Examples of link layer protocols are PPP or point-to-point protocol, as well as Ethernet. We will go deeper into Ethernet as a link layer or layer 2 protocol on the next networking basics NanoMOOC. The next layer is the Internet layer, where the units of informations are called packets, and the protocol is called IP, as we have already said. The packets content not only the information to be transported, but also additional data to route those packets along the network. This protocol enables transport from source to destination, what we call end-to-end communication, assuming that we have a complex thing, such as a network in between. To solve the problem of an end-to-end communication, we need addresses, so that we can locate the two ends wherever they are on the world. The addresses, also called IP addresses, must be unique to identify computers or other devices that we will refer to as hosts. As we mentioned before, examples of protocols from this layer are IP version 4 and IP version 6. Moving one layer up, we find the transport layer or layer number 4. So, if we already have end-to-end communication, what do we need more? The answer is to provide flow control, reliability, and avoidance of congestions. Or all or some of them, depending on the type of communication or data used. Reliability means that when we send something, we can be sure it will be received on the other side. Flow control refers to the coordination mechanism to adapt the speed of the communication flow to the path of the sender and the receiver. Congestion avoidance takes into account potential traffic jams or bottlenecks in the network to send the information at a slower speed if needed. Examples of protocols on the transport layer are TCP and UDP. We will explain both of them in the coming networking basic courses. The application layer is the last layer of the Internet model. The information here has no particular name, it is just called data, and this layer contains all the application protocols. Examples of application protocols are email, web browsing, SSH for secure remote login, these may be familiar to the majority of Internet users. We often call them apps, to shorten the name of Application Layer Protocol. Here, the number of protocols is huge. Every single app may have its own protocol to allow communication to flow and provide the desired content to each user.
I hope the concept of computer networks is much more clear for you. With its 5 layers, the Internet model is no longer a secret to all of you. But this is only the global picture. We need to talk deeper about each protocol to understand the networking basics better.